What you must be seeing on your screen is a dot on the left and a plus sign on the right with a yellow background color. We are going to perform a demonstration to find the blind spot of our eye. Yes, our eye has a blind spot. What is it though? And what does it mean? It is a spot on the retina of the eye where we cannot see the light when it's incident on it. I will explain its details a little bit later, but first I will prove its existence to you through an experiment. Okay, let's go back to the start again. Close your left eye and stay still with your right eye focused on the dot. Yes, I want you to stay still and concentrate with your right eye on the dot present on the left of your screen. Now with your left eye closed, I want you to slowly bring your face towards the screen. At some point in time, you will find that the plus sign on the right disappears. Yes, but in order for that to happen, you must focus only on the dot and nothing else. Okay, try it one more time. You can cover your left eye with your left hand, focus only on the dot and slowly come closer to the screen. Did you find the plus sign disappearing at some point? I'm sure you did. You can try it again. Left eye closed and focus on the dot. You can do the same thing using a blank piece of paper. Draw a dot on the left and a plus sign on the right. Make sure that there is nothing else written or drawn on the paper. Hold the paper at arm's length with one hand, preferably the right one. Close your left eye with the other hand and focus your right eye on the dot. Bring the paper towards you. Again, you will find that at some distance away from you, the plus sign disappears. At this distance, it will seem to you that there is no plus sign present. This distance is different for different people. And the other image disappears only at a particular distance. If you go closer, you will see the blurred version of the other image. And yes, even if you close your right eye and focus on the plus sign while coming closer, you will see that the dot will disappear. So next, let's get into the details of this and see how and why it happens. So there is a blind spot present in the eye. We have already discussed the structure of the human eye in our previous video. We note that the convex lens present in the eye focuses the light on the retina. And the retina has two types of nerve cells, cones and rods. These cells transfer the sensation to the brain through the nerves. These transporting nerves are present in front of the nerve cells. They are connected directly to the brain and hence they transfer the message to it. They go into the brain through this region. And this region is called the blind spot. The junction of the retina and the optic nerve is called the blind spot. Unlike the rest of the retina, this region does not contain nerve cells and hence no signal is transferred to the brain. The reason that we are not able to see the plus sign from the right eye at some distance is because at this distance, the lens in the eye focuses the light in this region. And since there are no nerve cells present in this region, no message reaches the brain. And that's why they say that every person is partially blind. It's because every eye has this blind spot. There is another interesting thing about the human eye that you got to know. And that is, any picture persists in the eye for about 1/10 to 1/15 of a second. That's right. It means that the brain retains the impression of that light for approximately 1/15 of a second after the source of that light is removed. That is very little time. This is referred to as the persistence of vision. And let me explain this in detail. I have many different images with me. Here's the first one, the second one, the third one, and the fourth one, and so on. There are many such different images. Now let me take you back to the first image. Let me show you successive images slowly. I will show you one image per second. Yes, this is how it will look. Now let me show you successive images at a rate of 2 images per second. This is how it looks. Now let me increase the rate to 5 successive images per second. How does this look? Our eyes still notice the changes. And now I increase it to 12 images per second. It almost looks as if it's a video, right? Then I show you 24 images per second. It looks like a video. This is because of the persistence of vision. The changes go unnoticed. They appear to be one continuous thing. When the images are flashed at a rate faster than 15 per second, the eye perceives the object as moving. The movies that we see also use this property of our eyes called the persistence of vision. What we see is nothing but still images shown to our eyes at a rate faster than 15 images per second. Usually, this rate is 24 images per second. However, recent movies have gone up to 48 images per second. Imagine 48 images shown to your eyes in just 1 second. The eye is such an important sense organ in humans. So it is necessary that we must take care of it. Just like any other part of our body, our eyes can also get damaged. In order to prevent that from happening, one must take preventive measures. We will discuss few of those in our next video.